Hi, my name is Peder Thompson. I'd just like to give you a short overview of my research program. First, just a little bit about myself. I'm currently a postdoc in Trondheim, Norway, and I received my PhD from the University of Nebraska-Lincoln in 2016. My research is in algebra, with an emphasis on homological methods, especially in commutative algebra. So today I'd like to talk a little bit about two of my more central projects. The first involves Cosupport theory, and the second is in the field of Gorenstein homological algebra. One of the more overarching themes in my work is to use resolutions to better understand ring and module structure. And in particular, I'm quite interested in using flat cotorsion modules and resolutions, a bit more of a special type of a module. Part of my work is to advocate that flat cotorsion resolutions provide a theory that is very parallel to the more classic theories of projective and injective resolutions in modules. Of course, I have a number of other interests as well, and I'm also very interested in involving students in my research area also. So first, let me tell you just a little bit about Cosupport. This is something I've been interested in since my dissertation work. The theory of Cosupport was introduced by Benson, Iyengar, and Krause, and it was in part motivated by Niemann's classification of co-localizing subcategories of the derived category. This theory has a very rich history. In some sense, it's dual to the more classic theory, a support theory, but there are a lot of subtle differences that require a lot fundamentally different techniques to work in this area. The definition of Cosupport you can think of in a lot of different ways. For instance, you can define Cosupport in terms of completion and co-localization. The definition I've put up on the screen here is that you can think of Cosupport as the set of prime ideals, such that when you hom the residue field of the local ring into your module or complex, you get something that's non-trivial in the derived category. Probably my most central result in this topic is that the cosupport of a module or complex can be detected by a minimal flat cotorsion resolution. And of course, you have to first answer the questions about what a flat cotorsion resolution is, and whether such a thing exists, and whether you can find a minimal flat cotorsion resolution. And these are kind of the central part of my work on this topic, both on my own and with my collaborator Nakamura as well. I've also shown that the cosupport of a finitely generated module need not always be a closed subset of the spec R, and also that the cosupport of a countable ring contains all prime ideals. These are, in some sense, partial results, and there are a lot of open questions still in this direction. It's not known, for instance, whether the cosupport of a finitely generated module is specialization closed. And it's still a very interesting question, considering what the cosupport of a ring in general looks like. And so these are areas that I'm actively thinking about today. Let me also talk a little bit about my work in Gorenstein homological algebra. This work is largely joint with Christensen and Estrada, where we develop a very general notion of totally acyclic complexes and their associated Gorenstein objects. And this is very much motivated by the flat cotorsion theory. And it not only recovers the more classic Gorenstein projective and injective modules and dimensions, it also introduces a new Gorenstein flat cotorsion module and dimension as well. And there's a number of applications of this, but sort of the primary application and also the motivation for developing the framework in the first place is to extend work of Buchweit's to a non-affine setting. Very briefly, Buchweit's considered equivalence between a singularity category of a ring, the homotopy category of totally acyclic complexes of projectives, and the stable category of maximal co-Macaulay modules. And we show that for a semi-separated Noetherian scheme, there are analogs of these categories, and they are equivalent when one would expect them to be equivalent. I will throw up a few references here and just mention that everything I talked about here, as well as a complete list of my publications, can be found both on my website and on the archive. Thank you.